Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 5, Section 4, Inverses, Contrapositives, and Indirect Reasoning. Okay. So I'm going to go back to a previous chapter, Chapter 2, where we learned one other definition, and I'm going to put it at the top. So the converse is the converse of a statement switches the hypothesis and conclusion. Okay. And if you want to take a look back in our Chapter 2 notes, you can see where we did converses and conditional statements. Okay. So negation is when you take the opposite truth value. So to negate true is false, to negate false is true. Now we have two more types of statements that we need to learn about. First one is inverse. The inverse of a statement negates both the hypothesis and the conclusion. So the inverse negates them, but it doesn't switch them. Okay? And then the contrapositive switches the hypothesis and conclusion, and it also negates both. So from this section, we need to know what a conditional is, you need to know what a converse is, you need to know what an inverse is, and you need to know what a contrapositive is. And we'll do some examples. Okay. So here's a conditional statement. If a figure is a square, then it is a rectangle. So I want to write the inverse and the contrapositive, and while I'm at it, I'm also going to add the converse too. Okay, so conditional, first I'm going to do the contrapositive. So the contrapositive is when I switch the hypothesis and conclusion and I negate them both. So if a figure is not a rectangle, then it is not a square. The inverse is when I negate them and I don't switch them. So if a figure is not a square, then it is not a rectangle. And the last one, our converse. Converse is when you switch the hypothesis and conclusion, but you do not negate either one of them. So if a figure is a square, if a figure is a rectangle, then it is a square. So one of the things you need to be able to do is for any statement, you need to be able to write any of those, contrapositive, the inverse, or the converse. Now, what we're going to do in class, we're going to make up a table to do this, is we're going to be taking a look at what are called equivalent statements. Equivalent statements have the same truth value. Now, we basically have four statements. We have the conditional, we have the contrapositive, we have the inverse, and we have the converse. Well, there are two sets of these that are basically equivalent statements. In other words, if the hypothesis and the conclusion are true or false, you'll get the same answer for each one, no matter how you say it. And we'll make up a table and do what's called truth values, and we'll take a look at those. But for right now, you just need the definition of what an equivalent statement is. So the next thing I have is a table that's from your book, and it kind of consolidates what we have. So we've got a conditional statement, and we have this symbolic form for it. If P, then Q. We learned that before and how we read it. So if an angle is straight, then its angle is 180. To negate it, we can add this little tilde here, and this little tilde means not, so not P. Okay, so an angle is not straight. The inverse is when we negate both a hypothesis and conclusion, but notice we still have if P then Q, but instead we have if not P then not Q. So if an angle is not a straight angle, then its measure is not 180. And the last one we have is the contrapositive, and this one we switch them and negate them. So notice they switch P and Q, and they put the little tilde in front of both of them. So this one is if not Q, then not P. So if an angle's measure is not 180, then it is not a straight angle. Okay. So one of the things we talked about before was there are actually several truth values for a conditional statement. You know, the conditional statement has a truth value, and then the hypothesis and conclusion can have their own truth value. So here's an example. If it is Friday, then it is snowing. Okay, so that is, if you take the whole thing as a conditional statement, it might be true, it might be false. Okay, it depends on if it is Friday, it is actually snowing. Okay, but we can talk about this statement on Thursday, and it can still be a true statement. Okay. The hypothesis wouldn't be true because it's not Friday, it would be Thursday, but the statement as a whole could still be a true statement. Okay? Now the conclusion has its own truth value, you know, whether it's snowing currently at the time or not. So what we're going to talk about is what makes the hypothesis and the conclusion true or false, and how those relate to whether the conditional statement or the converse or the inverse is then a true or false statement. But one thing to remember back from Chapter 2 was this idea that a conditional has its own truth value, and the hypothesis and conclusion also have truth values. Okay, so a statement can be a true statement, and the hypothesis and conclusion could be false at the moment. So an example of that would be, you know, it's Thursday, and I say, if it is Friday, it is snowing. Okay, currently it's Thursday, so the hypothesis is false. Maybe it's Thursday and it's not snowing, so the conclusion is also false. But it still might be true that on Friday it snows. Okay. Indirect reasoning is a reasoning in which all possibilities are considered, and then all but one are proved to be false. Okay. It's a great way to prove that something's not true. Okay. You basically assume all the truths, show that none of them can happen, and then you can say, well, then if none of these are true, then this has to be a false. Okay? An indirect proof is a proof using indirect reasoning. And there are 3 steps to writing an indirect proof. Step number 1 is you state an assumption that's actually the opposite or negation of what you want to prove. So if I want to prove that if it is Friday, then it's snowing, what I want to prove is that it's snowing. So what I would assume is it's not snowing. Then what I do is I show that this assumption leads to a contradiction. In other words, if I make this assumption that I really don't want to be true to begin with, I get a contradiction that can't happen. Okay, so my step number 2 is to show that I get a contradiction if I make this assumption. And then my last step is to conclude that the assumption must be false and that what you want to prove is actually true. So we're going to do several types of indirect proofs. We're going to do more like, you know, if it is Friday, it's snowing, kind of like just logical ideas, but we are also going to use these in proofs. It's especially important in the next chapter where we do quadrilaterals. and we have to prove things like kites and trapezoids. Those are the two ones that are going to use a lot of indirect proofs. Okay, so read the conditional statement, think about what is given and what you're trying to prove, and then give the steps of an indirect proof. If Jaylene spends more than $50 to buy 2 items at a bicycle shop, then at least one of the items costs more than $25. Okay. So basically what I have here is a conditional statement. So step number 1 is I am going to assume the opposite of what I want to prove. So I want to prove that at least one of the items costs more than $25, so I am going to assume. Now, when you do this, you have to make sure that you assume everything but what you're trying to prove and you show they can't happen. So at least one of the items costs more than $25. Okay? So if I write here at the top, I've got item 1 and item 2. Okay? I'm going to write all the possibilities. So I could have one of them be greater than $25, and the other one could also be greater than 25. I could have one be greater than 25, and the other one be less than or equal to 25. I could also have this one be less than or equal to 25, and this one be greater than 25. Or I can have them both be less than or equal to 25. So at least one item costs more than $25. That would be this, because there would be at least. This one would also be at least one item. This would be at least one item. This is the only one that I have to assume is true and show doesn't work, because the rest actually fulfill that at least one item costs more than $25. So I am going to assume both items cost less than or equal $25. Now, what I want to do is show that this couldn't happen. Okay, so she spent more than $25. So if both items are at least less than or equal to $25, the most they can be is $25. So if I add the two $25 together, that's going to be the most amount of money I'm going to spend. This would be the greatest amount I could spend. So if I add them, I get $50. And here's where I take a look at what I have, and in this case, she spends more than $50. Which means that this can't happen. So here's one of the most important steps of my indirect proof. But this contradicts the statement that Jaylene spent more than $50. So now what I could say is, so our assumption must be false. that both items cost less than or equal to $25 is false. Therefore, it must be true that at least one item is more than $25. So the important things that the proof has to have is we do have to have some sort of contradiction step. We do have to have some statement that says that our original assumption is false. And then our last statement in our proof is going to be, therefore, basically the negation of what we said in our initial statement must be true. One of the things you have to make sure is when you do this step is that you show that every case other than the one you're trying to prove is false. Okay? So in this case, I did that little table at the top to help me to make sure that there was only one case I had to look at, and that's where they were both less than or equal to $25, because every other case I have fulfills that at least one of them is more than $25. And that's it for today's video. We are going to spend a couple days practicing this and writing some proofs. So thank you for watching. Have a great day.